Lesson 1.14, Trigonometric Functions. In this course, we're going to learn about 6 different trigonometric functions. The ones that you're used to are the sine of x function, cosine of x, and tangent functions. And what we were used to in the past is by dealing with the period in terms of degrees. Now, in the last lesson, I introduced radians to you. So we're going to graph our trigonometric functions in radians for all of this course. I'm just showing you the completed lesson just so I can briefly talk about each graph, and you don't have to watch me graph every single one. But here, we'll just bring your attention to the sine of x function with the scale in degrees. So it looks like so. It has a maximum of +1 and minimum of -1, and an entire wavelength is 360 degrees. Now, if we convert those degrees, the 90, 180, 270, 360, into radians, we'll get pi over 2, pi, 3 pi by 2, and 2 pi, making an entire wavelength 2 pi radians long. The domain and range will stay the same. This is the only difference that we're going to be doing in grade 12. So what do you notice about the two graphs? Is there anything similar, anything different? It should be that everything is similar except that the x-axis scale is in radians. If you want to just refresh your memory on what the cosine graph looks like, that's where we start at the maximum with the radian at 0 on the x-axis, comes down to a minimum, and then returns back to its maximum. The tangent graph has some asymptotes in it. So some of you might be familiar with this because maybe your school taught it in grade 11, but some schools did brush over it. So the tan graph has some asymptotes here. Just make sure you know where they are. And the domain will state them here. At x cannot equal pi by 2, 3 pi by 2, 5 pi by 2, and if we kept going, it would go in that same pattern. How do we know the location of the vertical asymptotes in a tan graph? Well, I just want to bring your memory back to trig identities, where tan of x is the same as sine x over cos x. So when the cosine of x is equal to 0, or in here, for example, at pi by 2 and 3 pi by 2, that's where you'll see your asymptotes, because we can never have 0 in the denominator. However, we'll get x-intercepts whenever sine of x is equal to 0. So sine of x equals 0, just looking at your graph, at 0, 180, and 360. Or I should have done the radians there, sorry. 0, pi, and 2 pi. So going back, at 0, pi, and 2 pi, you'll see that that's where your x-intercepts are. And you'll get an x-intercept because sine of x is in the numerator of tan of x. The 3 new functions that you're going to be looking at graphing in this year are the cosecant graph, which is the same as 1 over sine, the secant graph, which is the same as 1 over cos, and last but not least, the cotan graph, which is the same as 1 over tan of x, or cosine of x over sine of x, just flipped. So just study these graphs briefly. You'll see I've already written the domain and range. There are no amplitudes in this these inverse functions here, just because you're going to see that they go all the way to positive infinity and negative infinity. And you'll see that they are the exact opposite of the sine graph and cosine graph. So take some time to study what these graphs look like. And in the next lesson, we'll look at how they transform. If you just scroll down or go to your next page, I have a beautiful summary here in this chart. So make sure you fill this out as well when you get the chance. You can take a look at the completed note that I have posted. And then just make sure you get your practice done.